Notes?
No, but the formulas are on there. You'll be okay. Anyone need a calculator or notes or a pencil?
I did because I didn't have that.
Okay, so this is like a 2-day lesson. Today we're just focused on finding the area of a regular polygon, and we'll worry about composite figures tomorrow. What do you guys know about a regular polygon?
That's like 5 sides.
What makes it regular?
All the sides are the same.
Yeah, all the sides are the same. So we have to learn a few new words or ideas to help us find the area of it, but it's not so bad. It's not so bad. Just be organized in your work and you'll be fine. Okay, so just a little review here. So we have a figure here, right? We have the circle with a pentagon inside. When you have a circle outside a shape, we call that being circumscribed, and the figure inside is inscribed in your circle. So the pentagon is inscribed while the circle is circumscribed to the pentagon. So why is this important to us? Well, when we find the area of a regular polygon, sometimes you have to use a radius for the apothem. So now if you look at our picture there, what would be the radius? Or a radius, there's 2 there. What do you guys think? You know, a radius of a circle goes from the center to the outside. So what would that be?
A or B.
We need 2, because it's a segment, right? So you need 2 letters. I heard someone say AP, that's one. What's another one?
Oh. EP?
EP would be one if it was drawn, yep. BP, yep, PC. All those would be radii of your circle and pentagon. Now a segment that's drawn from the center to the side of your pentagon is called the apothem. So that goes from the center of the circle or the center of your figure to just the side of the polygon. And it's always perpendicular. We'll need that for sure when we find our area of our pentagon. And the last piece of information we might need is a central angle. And the central angle is kind of what it says. It's in the middle, right? It goes from the center of our circle and has the 2 radii bounding it. And you might want to circle on the bottom how you find it is you take 360 divided by the number of sides. Right, since it's a regular polygon, we know all of our sides and angles have to be equal. 360 divided by n is how we find that central angle. So right there. So a lot of information. So the first 2 examples, we're just going to practice labeling these things in a diagram that looks like that. So on this first one, what is our center?
K.
K. Easy enough. So you're going to put K there. What's one radius?
HK.
HK, yep. Since there's another one drawn, what would that be?
GK.
GK. Perfect. The apothem. Yep, goes from the center to the side of your polygon. Now they want us to name the central angle. So it goes from one radius to the center to another radius. So how would you name that? GKH. Angle GKH. How can we find that measure? At 360 divided by the number of sides, which is 4. So what is that? 360 divided by... It probably is 90. Correct. There you go. 90. Okay, you guys get a head start on the next one. Same exact kind of problem.
What's 90?
That central angle. The central angle is 90. So you guys try the same thing with a different picture. How do we do? Are you okay? That's all right. Okay. So if we wanted to find the area of that hexagon here, we have a nice little formula. And it's half the product of your apothem times your perimeter. So you can write it either way, whatever way you prefer. But the little a stands for the apothem. So that segment that's inside, that goes from the center to the outside of your polygon, times the perimeter. So the little a stands for your apothem, p is for perimeter, multiplying together, divide by 2. Okay, let's try one. So we're going to find the area of the regular polygon, round to the nearest 10. What two things do we need in our formula? Apothem, so our little a, and perimeter. So I like to label those off to the side because those are the two things I need to plug in, right? Is there one right now I can find right away by just looking at our picture?
Yeah, perimeter.
Perimeter, that's pretty easy, right? Because all your sides are 3, they're the same. So I'll just do P for perimeter, 3 times, there's 6. So what do we get? 18. Okay, so that's one of our pieces. So I'm going to put 18 over here so my work's neat and I know what's going on. Now we're looking for our apothem. What segment is that inside our picture? BD, right? So I'm going to take this triangle here and I'm going to kind of blow it up larger down here so I can see it better, okay? So we're trying to figure out what this guy is. Now this is where that idea of the central angle comes in because we can use trig and special right triangles to help us figure out missing lengths. So to find what this big central angle would be, we take 360 and divide by what? 6. You guys tell me what you get when you do that. 60. Now that's this big angle here, but I only want half of it. So I'm going to divide it by 2. So what do we get? 30. Very good. So this angle right here is 30. You guys know what this little length right here would be? 1.5, right? The whole thing's 3, 1.5. So what kind of a triangle do we have?
300.
Yep, a special right triangle. If our short leg's 3, what's our long leg? 1.5 root 3. You just plug it in. So we just found our apothem right there. 1.5 root 3. Now we have the pieces that we need for our formula. Plug in 1.5 root 3 times 18 divided by 2. Careful with your parentheses, that you close them out if you have to. Like 23.4 if you go to the nearest 10.
Yep.
23.4. So I know it's not the most straightforward problem to solve, but you guys know how to do each piece individually, right? And just being able to put it all together. Okay, let's try square. Same process. We still need our apothem and our perimeter. By just looking at our picture, do we know either of those things?
No.
Unfortunately, no, we don't. Here's our right triangle, right? I'm going to blow that up right here so you can see it a little bit better. So what do we have to do first?
Just find what the bottom is.
Yeah, we eventually have to find the bottom and the apothem, but to figure out what that angle is, you guys remember how we did that?
45. Alright, something like that. 360 divided by 4.
Perfect. 360 divided by 4.
And then divide by 2 again.
Yep. 90 would be like this big angle, the big central angle. We want half of it, so 45.
So it'd be 3.5 root 2. Right?
Yep, you can leave it like that if you wanted, or decimals are okay too, if you just want to divide by root 2. So if we kind of lost you there, this is a 45, 45, 90, right? If your hypotenuse is 7, how do you get x alone? How would you get x alone here?
Use backtrack.
Yeah, so how do you undo times by root 2?
Use times by 2.
Right. So 7 divided by root 2 is what approximately?
3.5. 5. Or no, 4.9.
4.9.
And they're both that early.
Yep, so both of your legs are 4.9. So your apothem's 4.9,
Oh. And then,
but your side length, what would this whole side be?
don't you just times 1.9.2? Or
Yeah.
times 2?
Times 2?
And then times 4.
So what is 4.9 plus 4.9? 9.8. Now we can find our perimeter. 9.8 times 4. What are you guys getting?
96.
I think you might have solved the problem. I'm not quite there yet.
Oh.
Good answer, though. Good answer. Perimeter should be what, folks? There you go. Now we have all of our pieces. Area equals 4.9. You guys okay with 96? Okay, why don't you guys get a start on this one? A head start until you get stuck. This will be the last one like this in your notes. That's with a special right triangle. So we're going to find your perimeter and the apothem. That's what you got to figure out first.
And what's that's just one. Like half of it.
Where the apothem goes from the center down. That would be your apothem.
Is it 2028?
I got 7.2. Anyone get 7.2? No one's there yet? No. Okay, do we agree that this is a 30, 60, 90 triangle?
Yeah.
Okay, so your long leg is 2. How do you work backwards to get your short leg from here? Divide by root 3. So 2 divided by root 3. 1.2.
Oh.
So that's your hypotenuse, 1.2. So I think that's the tricky part, just making sure you have your special right triangle facing turned the right way. Because now we have all the pieces. 1.2 times divided by 2. Now are we getting 7.2?
Yeah.
All right, and our last one here, I think, is an octagon, right?
Yep.
Okay. Same process. Top and then perimeter, we gotta find those first. Do we know either? We do know our apothem, right? 8, so we just gotta figure out our perimeter. I'm gonna draw out this right triangle here, so I can see it better. I know this is 8, and we gotta figure out what our side length is. Yep, figure out our angle, so 360 divided by 8. Yep, 45.
So isn't it just 8 for the, or half the perimeter is 8, or no? Like
I
half
wish it
the
was,
side-
but it's not. 45 is our big central angle, but we only
Oh.
want half of that, right? 22.5. Is 22.5 a special angle to us? No, so we have to use trig, but that's okay. If you label your sides, what side is x? Opposite. What side is 8? What trig function uses opposite adjacent? Tan. So tan 22.5 equals x over 8. Multiply the 8 over. What are we getting? Okay, now careful. That's just this little piece here. What would your whole side length be? 6.6. So your perimeter, 6.6 times 8. 32.8? Let me see, that seems too small. There we go. What are you guys getting for a final answer?
211.2.
I know it seems like a lot of work and you might be really confused, but I think once you start getting into it yourself, you might think that makes more sense. I'm hoping you will. Okay, just reviewing quick. What is that pointing to? That's the apothem. What about this one? Radius. Yep, that's a radius. This one?
Middle.
Apothem. Yep. Yep. What are these? I'm just trying to lighten the mood because everyone just seems to hate this lesson. So. Better luck next time. Sorry, folks. I tried. Really trying here. Tough crowd.
It's Monday.
It is Monday. We only have, what, 3 more Mondays left? Gotta savor it.
Listen. I have 4 weekly assignments. I have 4 weekly assignments. Huh?